This fourth in a series of Getting Started presentations is called Bob Has an APT. This presentation looks at an audit trail file consisting of an advanced persistent threat exfiltrating data off this computer. So in this presentation, we began, as we always do in the Getting Started series, by downloading and analyzing a sample audit trail file. We see how Audit Explorer can alert us that an unusual program is running, possible evidence that you have some malware in your system. We also see how Audit Explorer can help us understand this particular attack. Finally, we show how we can proceed in reverse, where another sensor, like an Einstein 2 network monitor, detects something suspicious and you have been asked to look into it. Begin by downloading sample audit trail file, Bob Has an APT. Now open the BSM audit trail file you just downloaded. The first thing we notice is that there was an unusual execution event. To see more details about that event, go to the Display pop-up menu and select Executions. Here we see a program named Search Copy running inside the directory .hidden. Naming a directory like this generally keeps it hidden from Bob or anyone else looking in his home directory. To get more information, just double-click on the event. This brings up the Process Details window. We see in the Children section that Search Copy started a lot of additional processes to carry out various subtasks. We could click on each of these subtasks to get more information about them, the files they read, and so on. For example, here we see gzip read the files uploads.tar and wrote the file uploads.tar.gz. And certainly in a full detailed examination, you'd want to go through all these events with a fine-tooth comb. But in cases like this, where a lot of children processes were created, we have a quicker way to get an idea of what was happening. Open the Preferences window. About halfway down, there is a group called Child Process Display. By default, for child processes, the full path to the process's program name is displayed. For example, we see /user /bin /mdfind and /bin /copy. This lets us know exactly what program was run. But if I switch to program name plus arguments, the path to the program is removed, but the arguments are added. In many cases, just looking at the arguments can give us a pretty good idea of what's going on. So let's walk through this list of subtasks. The first command is mdfind. This is the command line program to the Spotlight utility. From these options, we see that the software is searching in Bob's Documents directory for any files containing the word classified and that were created or updated in the last 2 days. Next, we see the software making local copies of the text document Operations Plan and the presentation Navy Spring Plans. We would need to verify this, but we can guess that these were recently created or updated documents with the word classified in them. Next, the software packaged up these two files into uploads.tar, then compresses that tar file, and then encrypts that file, giving it a new innocuous name of test data. At this point, there's a little bit of a break in the pattern. We only see the shell process, no arguments. We need to zoom in on this process by clicking it. Here we see it created its own child process, which ran the curl program. From these arguments, we can see that the software uploaded the file, test data, to a remote server over a standard web connection. Remember, the test_data is the encrypted, compressed tar file containing the two documents with the word classified in them. In short, Operations Plan and Navy Spring Plans were just exfiltrated out of the network. Popping back up, we see the last 3 steps securely delete the files created by the search copy and its children. So what does all this mean? Well, 2 files were just exfiltrated out of this computer. Because the data was encrypted before being transmitted, any network monitor or firewall, if it happened to be monitoring outbound web traffic at all, will only see the file called test_data that looks like it contains random bytes. Finally, because all the temporary files were securely deleted, if someone comes to perform disk forensics on this computer later, they will never find these files on the disk. But because we were running audit trails, we were alerted that a non-standard program was run. We know exactly where it is and how it started. We know what it did and how it did it. And we know what data was compromised. It is pretty hard, if not impossible, to do this with any other data source. And we could do it almost effortlessly. But suppose we approach this from a different perspective. Perhaps we were busy and hadn't checked the Notables tab or the Filters tab. But then we get an email from the Department of Homeland Security who's monitoring our network with their Einstein 2 network monitor. They've seen a number of connections sending data to this one remote server, and this has made them suspicious. Unfortunately, when they look in the network packets, they just see what appears to be random data. One of the network connections came from our computer, so they ask, "Do you know anything about it?" No problem. We switch to the network tab, type in the remote server address, and click search. Boom. We instantly know what process was responsible for that connection. And as always, for more details, just double-click on the process. Immediately, we see the file that was sent across the network. Where did this file come from and what was in it? In this particular case, just follow the ancestors up 2 notches. We quickly find the sequence of tasks that created this file. Working our way backwards through the commands, we quickly see what files were exfiltrated. And we know all these subtasks were started by the program called search copy that is nestled away in the directory called .hidden. So starting from some vaguely suspicious activity detected by a network monitor, we can quickly identify the process that created that connection, the file that was transported across that connection, the contents that went into that file, and how it was all done. From vaguely suspicious event to concrete knowledge in a matter of seconds. Because you are running audit trails, suddenly your network monitors are a lot less frustrating and a lot more useful. That is it for the Getting Started series. In future presentations, we'll move beyond these simplified examples and look at some real-world analysis. We see how Google applications look virtually identical to advanced persistent threats. We will see how you can set up honeypot files to catch some bad guys. And we'll see how you can put up virtual monitors around your important files.